Yeah. So this is the next chapter, chapter 4 from your NCERT math textbook, linear equations in two variables. All right. So let me read the contents of this slide. Ax plus b is a standard form of a linear polynomial in one variable x, where a and b are real numbers and a should not be equal to 0. That is, the coefficient of x should not be 0. Because if the coefficient of x is 0, then the x term itself will be absent, because 0x is nothing but 0. Then there's only b, right? Then it is not a linear polynomial. What makes it a linear polynomial? The highest power of the variable involved should be 1. What makes the polynomial a linear polynomial? The highest power of the variable. Okay, here x should be 1. So in ax plus b, x is the variable and the power of the variable x is 1, and that's the highest power. And that's why we say that this expression is a linear polynomial in one variable x. Variable is x here. What's the power of x? 1. And that's the highest power of x in this expression. So the highest power of x is 1. And that's why it's called a linear polynomial. Linear because the degree of the polynomial is 1. What is degree? The highest power. The highest power is 1, so the degree is 1. And if the degree is 1, it's a linear polynomial, right? So the coefficient of x, which is a, should not be 0. Because if this is 0, then it is 0x and the x term itself is not there. Then it will no longer be a linear polynomial because you will have only b. Where is x? Where's the x term? It's not there because it is 0x. So then it will no longer be a linear polynomial. So the important condition is a should not be equal to 0. B can be 0 because if you take this example 5x, 5x is a linear polynomial. 5x is a linear polynomial in one variable x because it can be treated as 5x plus 0. And when you compare this with ax plus b, a is 5 and b is 0. Okay, so 5x is a linear polynomial. 5x is a linear polynomial in one variable x because you can treat this as 5x, not 5x plus 1. 5x plus 0. You can't treat it as 5x is not 5x plus 1. 5x plus 0. 5x plus 0. So when you compare this with ax plus b, a is 5 and b is 0, right? Okay. Which means b can be 0. A should not be 0. B can be 0. That's why the condition is a and b are real numbers. A should not be equal to 0. All right. Now take this example, 3y minus root 5. So compare this with ay plus b because the variable is y. Change the variable according to the expression. So if you consider this example 3y minus root 5, 3y minus root 5 is a linear polynomial in one variable y. 3y minus root 5 is a linear polynomial. Linear because the highest power of the variable y is 1. So it's linear. Okay, so 3y minus root 5 is a linear polynomial in one variable y. Linear polynomial in one variable y. So if you have to compare it, you should just make a small change with the standard form. Instead of using the variable x, you should show the variable y. So ay plus b. The standard form will be ay plus b in one variable y. All right. So when you compare this with ay plus b, the value of a is 3 and the value of b is minus root 5. The value of b is minus root 5 because plus b is equal to minus root 5. Plus b is equal to minus root 5. So b is equal to minus root 5. Correct? Okay. Now, when a linear polynomial is equated to 0, it's called a linear equation. When a linear polynomial is equated to 0, it's called a linear equation. So here, if you equate this linear polynomial in one variable x, when you equate it to 0, it's called a linear equation in one variable x. when a linear polynomial in one variable x is equated to 0, when you say is equal to 0, it's called a linear equation in one variable x. So ax plus b is equal to 0 is equal to 0 is a linear equation. This is a linear polynomial. This one is a standard form of a linear polynomial. If you equate this to 0, this is the standard form of a linear equation in one variable x. Same conditions apply. A and b real numbers, a not equal to 0. Same conditions apply. Now, a linear equation in one variable has only one solution. Now, let's try to solve this one. We took this example, right, of a linear polynomial. When you equate this to 0, it's a linear equation. So now let's solve and find the value of x. What's the value of x? 3x is equal to minus 5. X is equal to minus 5 by 3. So now, left-hand side is 3x plus 5. In place of x, when you use minus 5 by 3, in place of x, when you use minus 5 by 3, what happens? We get 0. We get 0, which is the RHS. Which is the RHS? That is, this value minus 5 by 3 satisfies the equation. Upon solving 3x plus 5 is equal to 0, we get x is equal to minus 5 by 3. Now, this minus 5 by 3 is called the solution or the root of the linear equation. This value minus 5 by 3 is called the solution or the root of the linear equation. Just a second, children. Yeah, upon solving this equation, 3x plus 5 is equal to 0. We get x is equal to minus 5 by 3. So here minus 5 by 3 is called the solution or the root of the linear equation. All right. So what does that mean? So take up the LHS of the equation 3x plus 5. Now in place of x, use the value of x minus 5 by 3, which we call the root or solution. Okay, in place of x. So it is 3 into minus 5 by 3 plus 5, right? So 3 cancels. So we have minus 5 plus 5, which is 0. And that's the RHS. So when you use the value of x as minus 5 by 3 in the LHS, we get the RHS as the answer, right? When you substitute x is equal to minus 5 by 3 in the LHS, what's the answer? You get 0, and that's the RHS. So this means that minus 5 by 3 satisfies the equation. This means that minus 5 by 3 satisfies the linear equation. All right. And you will also understand that this will be the only value of x that will satisfy the linear equation. Now for x, you give any other value other than minus 5 by 3. For x, give a different value other than minus 5 by 3. You will not get 0. The equation will not be satisfied. All right. Satisfied means what? The value of the LHS will be equal to the value of the RHS. Here the RHS is 0, right? So what value of x will make the LHS 0? Only when x is minus 5 by 3, the value of the LHS will be 0. For any other value of x, you will not get 0, which means minus 5 by 3 is the only solution or only root of this linear equation. A linear equation in one variable x has not in one variable x, in any one variable, x, y, z, whatever variable. So a linear equation in one variable has one and only one solution. A linear equation in one variable has one and only one solution. There's only one value of the variable that can satisfy the equation. All right. Now, this solution can be represented, geometrically. So geometrically, the solution is represented by a point on the number line. Geometrically, the solution to the linear equation in one variable x is represented by a point on the number line. Now, here we got x is equal to what? Minus 5 by 3, right? So let's represent this on a number line. Draw a number line. Okay, 0. Now this is, so here the denominator is 3, right? So we'll say 0 by 3, 1 by 3, 2 by 3. Let me take a new slide, sorry. Zero, 0 by 3, 1 by 3, 2 by 3, 3 by 3, 3 by 3 is 1, 4 by 3, 5 by 3. So this is x, this is the point x is equal to 5 by 3. Then we have, oh, that was minus 5 by 3. Oh, wow. Thank you. Okay, sorry. Okay, then I'll go on the other side. Okay, 6 by 2, I'll stop here. So this is 2. So here we have minus 1 by 3, minus 2 by 3, minus 3 by 3, minus 3 by 3 is minus 1, minus 4 by 3, minus 5 by 3, minus 6 by 3. This is minus 2. All right. So this darken this point and say x is equal to minus 5 by 3. So this is how the solution. This is how the solution to the linear equation in one variable x is represented geometrically. This is how we represent geometrically the solution of the linear equation in one variable x. So the solution was x is equal to minus 5 by 3. So the denominator here is 3. So we say 0 as 0 by 3. 0, 0 by 3. Then we mark 1 by 3, 2 by 3, 3 by 3, which is 1. 4 by 3, 5 by 3, 6 by 3, which is 2. On the other side, minus 1 by 3, minus 2 by 3, minus 3 by 3. Minus 3 by 3 is minus 1. Minus 4 by 3, minus 5 by 3, minus 6 by 3, which is minus 2. So where is minus 5 by 3 here? Just mark that and write x is equal to minus 5 by 3. So this is how the solution is represented geometrically. So whatever is the denominator. So supposing you have x is equal to say like minus 11 by 9, for example. Okay. Let me take a plus 11 by 9. Okay. So I'll not take too much on the negative side. So it will be like minus 1 by 9, minus 2 by 9, 1 by 9, 2 by 9, 3 by 9, 4 by 9, 5 by 9, 6 by 9, 7 by 9, 8 by 9, 9 by 9 is 1. This is 1. 10 by 9, 11 by 9. So you have 12 by 9, 13 by 9, 14 by 9, which is, oh no, 14 by 9, 15 by 9, 16 by 9, 17 by 9, 18 by 9, which is 2. So now this is plus, children. I made it plus. All right. So here it is. X is equal to 11 by 9. So whatever is the denominator is 9, then we'll say 0 as 0 by 9. We'll call 0 as 0. This is 0. 0 will take it as 0 by 9. So then 1 by 9, 2 by 9, 3 by 9, 4 by 9. So which is 1? 9 by 9 is 1. Then 18 by 9 is 2. 27 by 9 is 3. On the other side, to the left of 0, minus 9 by 9. Minus 1 by 9, minus 2 by 9, minus 3 by 9. So minus 9 by 9 is minus 1. Then minus 18 by 9 will be minus 2 and so on. So you'll have to mark considering the denominator of the solution. Take the markings considering the denominator of the solution. All right. I'm clear here? Yes. Okay. So let's see this again. Ax plus b is a standard form of a linear polynomial in one variable x. The variable can be anything. It can be it can be x, y, z, t, u, m, n. It cannot be a or b. Then you should change the coefficients also. See, if the variable is a, then you must call you should just call it like ma plus n. Ma plus n. See, if you have to express this one, ma plus n, okay, is the standard form of a linear polynomial in one variable a. In one variable a, where m and n are real numbers and m is not equal to 0. That's all it is. So ax plus b is a standard form of a linear polynomial in one variable x. A and b are real numbers, a not equal to 0. Look at the board. When this linear polynomial is equated to 0, it's called a linear equation. So ax plus b is equal to 0. When you equate this to 0, ax plus b is equal to 0 is the standard form of a linear equation in one variable x, where a and b are real numbers, a not equal to 0. A linear equation in one variable x has one and only one solution. This solution can be represented as a point on the number line. It has one and only one solution, and this solution can be represented as a point on the number line. Very good. Linear equation in two variables x and y. All right. Ax plus by plus c is a standard form of a linear polynomial in two variables x and y. Let's take an example like 3x minus 7y. You can even say root 3x minus 7y plus or say minus 11 by 3. Okay, so now in this polynomial, how many variables you see? Two variables, x and y. We see two variables, x and y. Okay, what's the power of x? 1. What's the power of y? 1. So what's the highest power? 1. So linear. When will you use the term linear? When the highest power is 1. The highest power of the variable or the variables involved is 1. Then it's linear. So here there are three terms. 1, 2, 3 terms. Okay. And two terms have the variables x and y. There is one term with the variable x. There is another term with the variable y. The power of x is 1. The power of y is 1. So the highest power of the variables involved is 1. So linear. Linear polynomial. in two variables x and y. Linear because the highest power of the variable or variables involved is 1. That's why linear. Polynomial equation means you will have the equal to sign, equal to 0. That's an equation. Otherwise, it's a polynomial, linear polynomial. How many variables? Two variables, x and y. Okay. So this is an example of a linear polynomial in two variables, x and y. When you compare this with ax plus by plus c, what's the value of a? Root 3. What's the value of b? Minus 7. What's the value of c? Minus 11 by 3. The value of a is root 3. The value of b is, and the value of c is minus 11 by 3. Okay. Ax plus by plus c is a standard form of a linear polynomial in two variables x and y, where a, b, c are real numbers and a not equal to b 0, b not equal to 0. Actually, you should understand this condition. A squared plus b squared is not equal to 0, which means we'll talk about this later. This means a and b should not be 0 at the same time. That is, if a is 0, b should not be 0. If b is 0, a should not be 0. That's the meaning of this inequality. This is not an equality because you can see the not equal to sign. This one is an inequality. It's not an equality. Okay, so the condition is a squared plus b squared not equal to 0. That means both a and b should not be 0 at the same time. A 0, B 0. No, no. If A 0, no, B should not be 0. Or if B 0, A should not be 0. They should not be 0 at the same time. But A, B, C can be any real value. A, any real value. B, any real value. C, any real value. But A and B should not be both 0 at the same time. These are the conditions. When this linear polynomial is equated to 0, it's called a linear equation. Okay. So ax plus by plus c is equal to 0 is a standard form of a linear equation in two variables x and y, where a, b, c are real numbers and a square plus b square is not equal to 0. A and b should not be both 0 at the same time. A linear equation in two variables is represented by a straight line in the Cartesian plane. Okay, so now how do we represent the solution? How do we represent the solution of a linear equation in one variable x? It's a point on the number line. Linear equation in one variable x. Its solution is represented by a point on the number line. Now this one is linear equation in two variables x and y. Now this one will be a straight line in the Cartesian plane. When you try to represent this equation graphically, you will get a straight line in the Cartesian plane. So how to get that line, we'll see later. But it's a straight line in the Cartesian plane. Now, when we say it's a straight line, how many points do you find on this line? How many points can you find on this line? Line. What is the definition of a line? A line has no endpoints. It extends indefinitely. Satakshi is saying, she's saying, I want to answer. How many points are there on a line, Satakshi? Huh? No point? No point? Okay, no problem. Yeah. Yes. Yeah. How many? Infinitely many. Yeah. Correct, Gayatri. A line has no endpoints. Whether it is a line or a line segment, there are infinitely many points. There are infinitely many points on a line. A line extends indefinitely on both the sides. So how many points? There are infinitely many points. And every point on this line will be a solution to this linear equation, which is why a linear equation in two variables x and y has infinitely many solutions. Okay. There's somebody like you keep screaming, I have to take the notes, and that person is busy writing. No, I haven't finished. Please sit down. I'll just finish and then I'll come back to you. Okay. So ax plus by plus c is equal to 0 is the standard form of a linear equation in two variables x and y. The geometrical representation of this will be a straight line in the Cartesian plane. And we know that a line has infinitely many points on it. Every point lying on the line will be a solution. Every point that lies on the line is a solution to this linear equation, which is why we say a linear equation in two variables x and y has infinitely many solutions. Every point on that line is a solution to this equation. Why? Because those points will satisfy the equation. Okay, a point in the Cartesian plane has address in the form x comma y. So in the linear equation, for x, if you take the x value, and for y, when you take the y value and work the left hand side, you'll get 0, which is the right hand side. Every xy value from the line, straight line, every xy value from the straight line will satisfy the linear equation. So if the equation is satisfied, that's a solution to the equation. So from where does all this start? When you represent this linear equation in two variables, x and y, graphically, that is on the Cartesian plane, because two variables, we need two lines. Okay, two variables, so we need two lines, one horizontal line and one vertical line, which is the Cartesian plane or the coordinate axis. So when you represent this equation on a graph paper, you will get a straight line. Now on the straight line, there are many points. If you take a point, if you take the address of a point and put that xy value in the equation is satisfied. You take another point from the line and you put it in this equation. The equation is satisfied. Like this, you will see that every point lying on that line will satisfy the linear equation. Now this line has infinitely many points. So this linear equation in x and y has infinitely many solutions. A linear equation in two variables is represented by a straight line in the Cartesian plane. All the points lying on the line are solutions to the equation. Therefore, a linear equation in two variables x and y has infinitely many solutions. One variable x, only one solution. Two variables x and y, infinitely many solutions. Okay, linear equation. So you're learning two things. Linear equation in one variable x, linear equation in two variables x and y. Both linear only. That is the highest power of the variable is 1. Both linear. Linear equation in one variable x. Only one solution. Linear equation in two variables x and y. Infinitely many solutions. Because it's a straight line in the Cartesian plane and there are many points on the line. Now it's like a twist, you know. Now here comes a twist. But the thing is, every linear equation in one variable x can be treated as a linear equation in two variables x and y. Every linear equation in one variable x can be treated as a linear equation in two variables x and y. Okay, the given linear equation has, see, I'm repeating so that you internalize. Every linear equation in one variable x can be treated as a linear equation in two variables x and y. We'll see how. Okay. Yeah, Nuved, I'm sorry, I didn't ask you your question, Nuved. It'll be minus c. Yeah. Ax plus by is equal to minus c. Yeah. Yeah. Okay. Now, okay, with this question, I'll just say this. Now, supposing you have 3x is equal to minus 5y plus 11. Okay. And now they ask you to write out the values of a, b, and c. Write out the values of a, b, and c from this equation. You have to keep the equation in the standard form. Now, standard form, you can get two set of answers actually. I'll show you how. Okay, so watch carefully. I don't know what I wrote. I wrote this anything, whatever. All right. I wrote minus or plus earlier. No problem. Okay. So now see this. If the question is bring out the values of A, B, and C from this equation. All right. Okay. Now let's transpose. Now 3x minus 5y plus 11 is equal to 0. Correct? Correct, no? Okay. So what's the value of A? When you compare this with ax plus by plus c is equal to 0, what's the value of A? 3. What's the value of B? Minus 5. What's the value of C? 11. Okay. Now, this one, transposing we'll do in a little different way. We'll put 0 is equal to minus 3x plus 5y minus 11. Because we always like to break the rule, Okay. So what if we do like this? See, nobody can force us to transpose in a particular way, right? See, you need to have x, y, and the constant all on one side, and you should have equal to 0 on the other side. The rule is you need to have the x term, y term, and the constant all on one side and 0 on the other side. Yeah, we have 0 on one side and x, y, and the constant on the other side. Don't we have it like that? We've transposed 3x to the RHS. All right. So this is nothing but minus 3x plus 5y minus 11 is equal to 0, right? Yes or no? What's the value of A then? Minus 3. What's the value of B? 5. What's the value of C? 3 minus 3. Yeah. So you will get marks for both. See, because this is an exercise just to identify A, B, and C correctly. So if you transpose, if you do it like this, you should identify A, B, C correctly, like this. You're right. It's just for identification purpose. If you write it like this, then you're right. So for this question, you can give two set of answers. Whichever you write, you will get marks. But normally we do this transpose only. So most of us will get this answer. But even if you do this, you're right. I've not confused you, right? I've just explained the two different situations. I'm only trying to say that for A, B, C, you can give two set of values. Yeah. Both of which are correct. So see how it's treated. Now, which is the variable absent? Y. So show the absence of y as 0y. It's not 0.y. Into is, you can, instead of the multiplication sign, you can just put a point like this. 0 into y. 0, that's not a decimal point. That is not a decimal point. That's the way of writing 0 into y, which is 0y. So that point. So your question may be, how do I know that? Okay, then now Nuvesh will ask me, oh, then if you write 12.5, then how do I take it? Is it 12 into 5 or 12.5? No. If it comes with a number, it is 12.5 only. It's not 12 into 5. Okay. Yeah. If it's 12.5, it's not 12 into 5. Don't like mistake me. 12.5 is 12.5 only. It's not 12 into 5. So in situations like this, you need to treat this point as a multiplication symbol. Okay. So what is missing here? The y variable. So 2x plus 0y minus 5 is equal to 0. Whichever variable is missing, show that as 0x or 0y. That's all. If x is missing, put 0x. If y is missing, put 0y. Like this, Because what did we understand? Both A and B should not be 0 at the same time. One of it can be 0. A and B should not be 0 both at the same time, right? So here, when you treat it as AX plus BY plus C is equal to 0, B is 0, but A is not 0. That's the condition we understood. A square plus B square should not be 0. A and B should not be 0 at the same time. Yeah, they're not 0 at the same time. See, A is 2, but B is 0. Here, B is 5, but A is 0. B is not 0, A is 0. Here, B is 0, A is not 0. Here, A is 0, B is not 0. So like that. Yeah, just go through. I have nothing to say here. Just go through. So whichever variable is missing, that will be shown as 0x or 0y. Just go through that. All right? Yeah. Okay. So now we'll see the graphical representations of these equations. What you will be seeing in the next few slides are these equations here. Okay, are the graphical representations of these equations. All right. Okay. Okay, so the first one, 2x minus 5 is equal to 0. This one, 2x minus 5 is equal to 0. On solving, you get 5 by 2 or 2.5. So number line, it's 5 by 2, no? So 0, 0 by 2, 1 by 2, 2 by 2. I've explained that already. 5 by 2. So this is 0 by 2, then 1 by 2, 2 by 2 is 1, 3 by 2, 4 by 2, 5 by 2, 6 by 2. You understand this, right? So you need to mark off 5 by 2. This is 5 by 2. And this is the solution. X is equal to 5 by 2. Okay. Now treat the same equation. This is the geometrical representation of this linear equation on one variable x. We showed as a point on the number line. It's 5 by 2. So this is 5 by 2. Mark off this point and just write the solution. X is equal to 5 by 2. That's it. Now the same equation is treated as a linear equation in two variables x and y. So which is the missing variable y. So show that as 0y plus 0y. Correct? Okay. So now when you solve this, plus 0y has no value. So when you solve, you'll get 2, because plus 0y, what will you do with that? It's still 0, right? So 2x is equal to 5. X is equal to 5 by 2 or 2.5. Yes or no? When you solve this, you will not get why is it 0, y, which is 0. Right? So when you solve it, just ignore this. So 2x is equal to 5. Okay, and x is equal to 5 by 2. But the difference here is, the meaning is, x is 5 by 2. X is always 5 by 2 for any value of y, irrespective of the value of y. That's how we understand. That's how you're supposed to interpret this situation. Here, x is equal to 5 by 2 is interpreted differently. This x is equal to 5 by 2 means x is always 5 by 2, irrespective of the value of y. Because here we have two variables, x and y. You should not talk only about x, no. You're saying x is 5 by 2. What about y? X is always 5 by 2 for any value of y. So see here, see the table. X is always 5. See children, you can write 5 by 2 or 2.5, whatever. Both are the same, right? So don't get confused by why you have written 5 by 2 here 2.5. Write one of the two. Don't write both. That's all. Write either 2.5 or 5 by 2 everywhere. So see here, x is always 5 by 2 or 2.5, irrespective of the value of y. You can give any value of y. You can say it's minus 7, 0, 11, whatever. You can give any value. You can give any value for y. Yeah. So x is always 5 by 2 for any value of y. See, for y now you can give any value, 1, 2, 3, minus 1, minus 2, minus 3, any value for y. That's how you interpret this. X is equal to 5 by 2, irrespective of the value of y. See, so you should write x 5 by 2 everywhere for any value of y. Now plot this one. Plot these points. 2.5 comma minus 1. How do you plot 2.5 comma minus 1? This is 2.5 minus 1. It will be here. This is 2.5 minus 1. This one. This is 2.5 comma minus 1. Then plot 2.5 comma 0. This only is 2.5 comma 0. And then plot 2.5 comma 1. This is 2.5 comma 1. Right? Now join these 3 points and you get this line. So this is the line that represents the equation 2x minus 5 is equal to 0 when it is considered as a linear equation in two variables x and y. See, even if you have taken, say, like -1, -2, and -3, you will get the same line. Now, if you have this question, what if I take some other value for y? Will I get the same line? You will get the same line. See here, plot 5/2, comma -1. This is 5/2 and -1. Below that will be 5/2 or 2.5, -2 is here. 2.5 -3 will be here. Same line. If you take 6, 7, 8, you will be plotting it here. 6, 7, 8 here. So it's a line, no? All of you will get the same line. Your plotting points will be at a different place, but when you join those 3 points, it will be the same line. So you can see that when you treat the same equation as a linear equation in two variables x and y, the graphical representation is a straight line in the Cartesian plane. So how do you get this line? Whatever is the solution, when you have x is equal to 5/2, x is always 5/2 for any value of y. And plot this one. How do you plot? 2.5, comma -1, 2.5, comma 0, 2.5, comma 1. Plot the 3 points, join the points to get a straight line, and that is the graph of this equation. All right. Now we'll have to understand how to express this graph. So this graph is parallel to the y-axis, and it is at a distance of 2.5 units to the left of the y-axis. This graph is a line parallel to the y-axis at a distance of 2.5 units to the right of the y-axis. So 2x minus 5 is equal to 0 is a line parallel to the y-axis at a distance of 2.5 units to the right of it. So they'll just sometimes explain the nature of the line, and with that explanation you should construct the equation. The nature of the line will be explained to you. The position of the line will be described. With the description of the line, the position of the line, you should be able to write its equation. So now you can see here, if a line has to be parallel to the y-axis, there'll only be the x variable in it. Okay. Now let's read this and write the equation. We'll not read this. We'll write the equation of a line which is parallel to the y-axis. Parallel to the y-axis means you should write x is equal to. See, I don't know. Now we'll just assume that we don't know the equation. So I'm not. Says a dash there. Dash is a line parallel to the y-axis. So parallel to y-axis, so I'll write x is equal to. At a distance of 2.5 units to the right of it. Right of the y-axis. Right side of the y-axis is positive. Left side of the y-axis is negative. Similarly, for x-axis, above x-axis is positive. Below x-axis is negative. See here. This is the y-axis, right? Y-axis. This is the right side of the y-axis, positive. This is the left side of the y-axis, negative. This one is above the x-axis, positive. Below the x-axis, negative. With respect to the with respect to the y-axis, you will have the words right and left. With respect to the y-axis, you will have right and left. Right is positive, left is negative. With respect to the x-axis, you will have above, below. Above is positive, below is negative. From the words you can make of now, above means positive, so below is negative. Okay. Right means positive, left means negative, right? Okay. So just have to read it. Dash is a line parallel to the y-axis. The minute you read parallel to the y-axis, write x is equal to. Next is you should decide if it's plus or minus. Right of it. So plus, distance is 2.5. So plus 2.5. X is equal to 2.5. So the equation is x minus 2.5 is equal to 0. Okay. Now you will be wondering like, no, this is different. You have written something. It's okay. So x is equal to 5 by 2. Because 2.5 is 5 by 2, right? Now cross multiply. 2x is equal to 5. 2x minus 5 is equal to 0 is the equation. See, 2x minus 5 is equal to 0. Parallel to the y-axis, x is equal to. Distance is 2.5. 2.5. Right means positive. Left means negative. That's all. So these are the three, key things you should look out for to construct the equation. I'm repeating it. Parallel to y-axis. When you read this, you must write x is equal to. Next, at a distance of 2.5 units, let me take 5 by 2. So write 5 by 2. Write plus. So you don't have to show plus. X is equal to 5 by 2. So x is equal to 5 by 2. Cross multiply. 2x is equal to 5. 2x minus 5 is equal to 0 is the required equation. Now, if you want to show us two variables, then it will be 2x plus 0y minus 5 is equal to 0. That's all. Got the equation. Next one. So when you solve this one, you get minus 12 by 5. Minus 12 by 5. Look out for the denominator, it's 5. So minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, because the denominator is 5. So minus 12 by 5 is here. This is minus 12 by 5. This is minus 1. Minus 5 by 5 is minus 1. Minus 10 by 5 is minus 2. This is minus 12 by 5. And above that, you just write y is the solution. Y is equal to, write the solution above it. This is the point and write the solution. Y is equal to minus 12 by 5. Y is equal to minus 12 by 5. All right, children? You fine? Okay. All right. Now, two variables. So x is missing. So show x. Okay. And when you solve this, you will get the same thing. When you solve this, you will get the same thing. Y is equal to minus 12 by 5. Okay. Or minus 2.4, whatever. So y is equal to minus 2.4 means y is always minus 2.4 for any value of x. Y is always, just come from the beginning. See, this equation, when treated as an equation in two variables x and y, it looks like this. All right. Now, solve this one. It's 0x. So it's like you show 0x because we're treating it as a linear equation in two variables x and y. But when you work it, this is just 0, right? So 5y is equal to minus 12, x is equal to minus 12 by 5. Same thing you will get. Now make the table, xy table. Okay. So you can write it as minus 12 by 5, but for plotting purpose, 2.4 is helpful, right? To plot 12 by 5, because on the graph paper to plot 2.1, 2.2, 2.3, 2.4 will be helpful. So I've written 2.4. All right. Okay. So on the graph paper, so instead of writing 12 by 5, minus 12 by 5, write minus 2.4. Okay. So y is equal to minus 2.4 means y is always minus 2.4 for any value of x. Plot minus 1 comma minus 2.4. Where's minus 1? This is minus 1. And minus 2.4. Minus 1, minus 2. So this is say 2.5. So this is 2.4 minus 2.4, just one. This is say 2.5 minus 2.5. So above that is minus 2.4. So see, this is minus 1 and this one is minus 2.4. It will be between minus 2 and minus 3. Now plot minus 1 minus 2.4. Minus 1 minus 2.4 here. Then 0 minus 2.4. 0 and minus 2.4. This one. 1 and minus 2.4. This is 1 and here. These are the 3 points. When you plot, these are the 3 points. And when you connect them, you get a straight line. The 3 points will be collinear. They will not lie like this. They'll not be like this. That means you're wrong. If it is a linear equation in two variables x and y, the 3 points can be connected by the same straight line. If you're not able to, that means we've gone wrong somewhere in plotting or in solving. Somewhere we've gone wrong. Yes. Standing line like this. Huh? Yeah. These examples are not, because we're treating a linear equation in one. Whenever you treat, okay, good question. Whenever you treat a linear equation in one variable x as a linear equation in two variables x and y, you'll always get a line parallel to the x-axis or y-axis. Whenever you treat a linear equation in one variable x as a linear equation in two variables x and y, you will always get a line parallel to the x-axis or the y-axis. Or sometimes it will be the x-axis itself or the y-axis itself. When we treat a linear equation in one variable x as a linear equation in two variables x and y, that means originally it's not a linear equation in two variables x and y. It has only one variable x, but you are treating it as a linear equation in two variables x and y. Such lines will always be parallel to the x-axis or parallel to the y-axis, or it will be the x-axis itself or the y-axis itself. When you have equations like this, see, 3x plus 5y minus 7 is equal to 0. That is where the value of a is not 0, where the value of b is not 0. When the value of a and b is not, when either a or b is 0, it will always be parallel. A 0 or B 0, the value of A is 0 or the value of B is 0, then they'll always be parallel to the x-axis or y-axis. When A is 3, B is 5, like when both A and B are non-zero values, then you can get a line like it'll be like this or whatever. Clear? Okay. And more importantly, when the value of C is 0, there'll be a line passing through the origin. We'll see all that. Okay, when the value of C is 0, when the value of C is 0, then will be a line passing through the origin. If either A or B is 0, if either A or B is 0, it will be a line parallel to the x-axis or y-axis. If C is 0, then the line will pass through the origin. If you have non-zero values for A, B, and C, then no, the lines can be like, it will be a straight line. It can go like this. Okay. So when you plot these points and join, you get this line, and this is the line of this equation. 5y plus 12 is equal to 0. Okay. See, making graphs, we have some formalities. So here we're just trying to understand. That's why I've not marked very, you don't see the scale. There should be other details, but this is just to understand. So I've not given all the details in the graph. Okay. So this is the line. Write the equation above it. Now I'm going to go faster. So you can see the variable x. When you solve it, minus 7 by 4. So minus 1 by 4, minus 2 by 4. So minus 7 by 4. Mark that, and x is equal to minus 7 by 4. You should write it here. X is equal to minus 7 by 4. All right. That's all. This is how you geometrically represent this linear equation in one variable x. Treat it as a linear equation in two variables x and y. Like this. Okay, so you'll get the same answer when you solve x is equal to minus 1.75. You'll get the same thing. X is equal to minus 1.75. You'll get the same thing. So x is equal to minus 1.75 for any value of y. When you get x value, no, take that x value everywhere for any value of y and plot this minus 1.75. So where will it lie? Between minus 1 and minus 2. So this is minus 1, this is minus 2. So somewhere here. That is after minus 1.7 and before minus 1.8. 1.1, 1.2, 1.3, 1.4. 1.7 and 1.8. Between that is 1.75. All right. So minus 1.75, this one, and minus 5. So minus 5 is here somewhere. No? Then minus 1.75 and 0, this one. Minus 1.75 and 5. This is minus 1.75, this is 5. This is the point. So when you join the points, you get this line. So now let's frame this equation. It's a line parallel to the y-axis. So x is equal to. Distance is 1.75. We'll take 7 by 4. Okay, 7 by 4. Left of it, negative. Parallel to the y-axis, x is equal to. Distance is 1.75. You can take 1.75, which is also 7 by 4. So is equal to 7 by 4. Left or right? Left, so negative. Now cross multiply. 4x is equal to minus 7. 4x plus 7 is equal to 0 is the equation. So that's what it is everywhere. Now this is parallel to the x-axis. So y is equal to 1.1 units. 1.1 meaning 11 by 10. 11 by 10. Above it, positive. So cross multiply 10y is equal to 11. 10y minus 11 is equal to 0. This one is below. I think we didn't. I didn't show you this one, right? Like we didn't read and make the equation parallel to the x-axis. So y is equal to distance is 2.4 units below it. So 2.4 is 12 by 5. Below means negative. So you need not write minus here. I'll just change this. Because when you say below, you don't have to say minus. If you use for the distance, for the distance, when you use the plus and minus sign, you don't have to say above, below, left, right. Okay. But if you put the sign, if they say a distance of minus 2.4 units, 2.4 minus 2.4 means below only it is. Minus means below or left. When the distance is negative, it means it is below or it is left accordingly. When the distance is negative, if it is parallel to the x-axis, it's below. If it's parallel to the y-axis, it is to the left. When the distance is negative. So mostly when the negative symbol, when the minus symbol is used, that below or left may not be given. Sometimes they'll give you both. So don't be very strict with all this, okay? Minus கொடுத்துட்டு below கொடுத்துருக்காங்க எனக்கு கன்ஃபியூஸ் ஆயிடுச்சு. கன்ஃபியூஸ்லாம் ஆக வேண்டாம். என்ன கன்ஃபியூஸ்லாம் இல்ல. டிஸ்டன்ஸ் 2.4 பிலோனா நெகட்டிவ் அவ்வளவுதான். அதனால நான் வந்து -2.4 போட்டு ஒரு இன்னொரு மைனஸ் போட்டேன்னா பிலோனா மைனஸ் போடணும் இல்லையா? அதனால மைனஸ் இன்டு மைனஸ் பிளஸ் ஆயிடுச்சு. So like that. Don't do that. So actually, if it is minus 2.4 units, this word below is not needed. Not needed. But sometimes I'll give you both minus 2.4 and below. Don't get confused. So parallel to x-axis means y is equal to distance is 2.4 and it's below, meaning negative. That's all. That is a printing mistake. Minus 2.4 and above it, meaning the statement itself is meaningless. Can't be above and negative. Yeah. So then there's some printing mistake. So here y is equal to 0. One variable is, this is the point, y is equal to 0 on the number line. Okay, x is equal to 0. X is equal to 0. This is x is equal to 0 on the number line. Now, when you treat it as the equation in two variables x and y, y is equal to 0 means y is always 0 for any value of x. X is equal to 0 means x is always 0 for any value of y. And when you plot this, when you plot this, -8, 0, -8, 0 here, 0, 0, 7, 0. See, you get the x-axis itself. Plot this one, 0, -3, 0, -3 here, 0, 0, 0 and 4. You get the y-axis itself. Finished? Yeah. You can try whatever is comfortable for you from this page. Then I'll give you a different paper. If you finish this, I'll give you a different paper. So y is equal to 0, x is equal to 0. When you treat them as linear equations in two variables x and y, they are the equations of the x-axis and y-axis itself. Y is equal to 0 is the equation of the x-axis. X is equal to 0 is the equation of the y-axis. See, otherwise also it's easy to remember because what's the address of this point? What's the address of this point? This point? Okay, -6, 0. Okay, -6, 0. This one? -2. 2, 0. Okay, 2, 0. What do you observe? Y is 0. Y is 0. Y is 0. That's why y is equal to 0 is the equation of the x-axis. Tell me the address of this point. 0, 7. Okay. What about this one? -2, -3, whatever. Okay, so whatever. What do you observe? X is always 0. That's why x is equal to 0 is the equation of the y-axis. Because on the y-axis, x is always 0. On the x-axis, y is always 0. That's why y is equal to 0 is the equation of the x-axis. Because x-axis and y-axis are also straight lines. X-axis itself is a straight line. Y-axis itself is a straight line. Every straight line has a linear equation in two variables x and y. So y is equal to 0 is the equation of the x-axis. X is equal to 0 is the equation of the y-axis. All right. when you treat it as a linear equation in two variables x and y. See now, how do we know that we are treating it as a linear equation, two variables x and y? See, we are making this table and plotting. No, whenever you make the table and you plot, you're treating that equation as a linear equation in two variables. You've taken a table, you've made an xy table, taken some values for x and corresponding values for y. That means that equation is a linear equation in two variables x and y, or you're treating it as either it is already a linear equation in two variables x and y, or you are treating it as a linear equation in two variables x and y. All right. So what we saw in this presentation is the standard form. Okay. I'll just underline. Just see whatever I'm underlining. Okay. Okay. Write each of the following equations in the form ax plus by plus c is equal to 0 and indicate the values of a, b, c in each case. Easy, no? So an equation like this will be given. You should put it in the standard form and write out the values of a, b, c. That's all. Everywhere, that's what you have to do. So see here, this equation. Take the y term to the other side, so it will become minus 2y. Then write out the values of a, b, c. What's the standard form with which you will be comparing? You, Shiva? What's the standard form? What's the standard form, Sachin? What's the standard form of a linear equation in two variables x and y? Ax plus by plus c is equal to 0. So you'll be comparing the given equation with the standard form ax plus by plus c is equal to 0. Correct? So when you have an equation like this, you must cross multiply. 3y is equal to 5x. Cross multiply. Then you can take this to the other side. So 5x minus 3y is equal to 0. So what's the value? So it is 5x minus 3y plus 0 is equal to 0. So what's the value of A? 5. What's the value of B? Minus 3. What's the value of C? 0. Yeah. Yeah, then you'll get opposite sides. Yeah, I told you no earlier, you will get you can have two different set of values for ABC. I told you earlier. Yeah, you can. We'll get marks for both. So 3y is equal to 5x. You bring this here, it will be minus 5x plus 3y is equal to 0. So then A is equal to minus 5, B is equal to 3, and C is equal to 0. Correct. Both are correct. No, I think if we do this chapter beyond this point, it can get a little saturating. I'm not, but I'm just assuming that from your faces, at least from some of the faces here. So I just want to keep quiet for some time and put you on a test with some questions from coordinate geometry. Yes, children. Please come. Yeah, so this is coordinate geometry, as you can see. Try these questions. Yeah, we have started the chapter linear equations. We'll be continuing with this in the next class. Yeah. Friday was not recorded. I had sent the images on WhatsApp, no? Because yeah, because I think your children were engaged with working the questions which was given in the class. So I had nothing much to explain there. So I had only presented the answers and little discussion, and they were just helping themselves with the correction. But I think you've got all the images on WhatsApp. Correct? Friday's class was not recorded. No, it didn't need to be recorded because I was not saying anything much. I was only presenting the slides and children were checking their answer with what was on my presentation. Hmm. Gayatri, Shriya and Harsha, I'll end this meeting. I'll share a different link with you on WhatsApp. Please join the meeting using that link. All right?
Okay, ma'am.
Yeah.